All right, this is a review problem to get ready for the test. The problem is this: we have a table with block M1 sitting on the table. Static friction between the table and the block is 0.6. It has a mass of 20 kilograms. It's connected by two ropes, well, a rope to a knot right here, which is connected to a wall, and then a rope down here. So what we're going to do is solve this problem. We did one similar to this, but the angle was different last time. So we're going to call this T1, this T2, this T3. And in this case, we need three free body diagrams. We need one for the two blocks, one for each block, and one for the knot right here where they connect together. So for block M1, the free body diagram looks like this. We have tension 1 going this way. We have M1G. We have the normal force. And we have the friction force. And this is static friction in this case because it's not moving. For block M2, we have M2G and T2. And for the knot, where they connect together, we have T2, T1, and then T3 going that way. And that angle there is 30 degrees. So from our rules, we do the free body diagram first and we put everything on the axes. Well, all these are on an X or Y axes already. So the only one we have to take components of is T3. So this is T3 cosine theta here. Or we're just going to put cosine 30 because we already know what the angle is. And then going up is T3 sine of 30. Now I can do my F net X and F net Y for all of the separate free body diagrams. So we're going to start up here with the M1 and do F net X is equal to T1 minus the friction force. Since it's not accelerating, we replace this with 0. And we can just say the friction force is equal to T1, but the friction force is mu sub s times the normal force. And to get the normal force, we have to do F net Y. So F net Y is going to be equal to the normal force minus mg. This is 0, so the normal force is just equal to mg. Okay? Then we can plug that back into here. So I'm going to plug this into the normal force, and we get mu sub s times, and we got to be careful, this is m1. m1g is equal to T1. Okay? Now, we know here that T2, or F net Y, I should say, in this case, is T2 and mg. Now we got to be careful here. We call this direction positive, right? So I'm going to call positive down in this direction here. And positive is going to be this way and this way for the knot. So positive being down, this is going to be M2G minus T2. That's equal to 0, so T2 is equal to M2G. Okay. Then for the knot, we have F net X is equal to T3 cosine 30. That's positive. Minus T1. And I can set that equal to 0 as well. So T1 is equal to T3 cosine 30. But then I have to do F net Y down here. I got F net Y is equal to T3 sine of 30 minus T2. Oh, I'm sorry. I messed up. It's T plus T2 and minus T3. All right, this goes to 0, so we can say that T2 is equal to T3 sine of 30. All right, what we're really trying to solve for here, don't lose sight of that, is we want to figure out what M2 is. But we know M2 is related to T2, and so we'll have to use T2 from down here. So I'm going to plug in T2 here. So I'm going to go back up here. I'm going to say T2, which is T3 sine of 30 that goes in for T2 is equal to M2G. I still can't solve for M2 because I don't know what T3 is. But here, I have a T3 equal to a T1, so I can rearrange this and say, oh, T3 is equal to T1 over the cosine of 30. If I just divide both sides by the cosine of 30, I can replace that for T3. So this becomes T1 sine of 30 all over cosine 30 is equal to M2G. But T1 we have up here, so I'm going to plug that in for T1, and I'm going to get mu sub s times M1G, and sine over cosine is just tangent of 30 is equal to M2G. And then I just divide both sides by G. That goes away, and I get M2 is equal to mu sub s M1 tangent of 30. And that will be my solution because I know this, I know this, I know this, I can solve for M2. So M2 is going to be equal to 0.6 times 20 times the tangent of 30 degrees. And when I plug all that in, I get T3 M2, I get 6.9 kilograms. And that's your answer.